Hi everyone, my name is John Doherty, and in today's video I'm going to be showing you how to use the Pulumi Automation API with Python. In today's video we're going to be deploying a full stack system which includes a Django REST API, Celery worker pull, and NextJS web applications. We're going to be using a handful of external providers such as DigitalOcean, Auth0, Elasticsearch, Datadog, and 1Password, and there could be a few more in there too. I've tried to follow the best practices where possible. So this system is designed for a kind of high availability, high traffic environment. The stuff that I talk about in today's video is probably going to be overkill for, a very basic proof of concept project. If there's only one or two users, you can definitely do this for a lot cheaper using some other kind of off-the-shelf PaaS provider. I'm sure there's many out there. But again, this is more designed for, high availability, low latency, high traffic environments, using Kubernetes. In today's video as well, I'm going to be showing you how to use the GitHub Action runner and how to deploy your code from your GitHub repository, build your Docker images, and push that to your Kubernetes cluster and effectively roll out across to that new version with zero downtime as well. So let's get stuck into the details of this now. So like I say, the link's in the video description, so feel free to check this out. In terms of actually running this on your own local laptop, it's all documented in the README file. So you'll want to run poetry install, activate your poetry environment, and then run the Python main py. But one thing you want to do before doing that is you'll need to update the provider's py file to contain your API keys for the external providers such as Auth0, Datadog, 1Password, all that type of stuff. So it's all very easy to read. It's all declared quite explicitly what's needed. I've went and redacted all my own keys, of course. And then once you've provided your API keys, if we take a peek inside the main py file, this is where the magic happens with the Pulumi Automation API. But if I scroll to the bottom, I can see here the core of it. So I've declared this schema here, full stack deployment. I'm defining properties like what's the name of the project, what environments do I want to support, the type of instances that I want to deploy for an environment, what web applications I want to deploy. So it's very flexible. I can deploy as many web apps that I want. I can specify the type of authentication required. And then stuff around role-based authentication, it becomes very easy to manage as well. And then all of this is defined, and I just run this create stack command here. So we'll start to dig into the details now around how this all fits together and go into the specifics of each of the Pulumi Automation API modules. So one of the modules that we'll be using is the DigitalOcean Pulumi module. And before we can actually use the module, we need to set some config for Pulumi so that it can actually connect to DigitalOcean's API and operate on our behalf. So you want to generate a token, which you can do through the DigitalOcean admin dashboard. You'll get your token, and then you can reference this through your automation API script. So I'm saying I'm setting my token here. And I'm also going to be using the spaces access ID and secret key as well, so I can access the object storage within my DigitalOcean account. And what I'm also doing before that as well is that I'm installing the DigitalOcean plugin to the workspace of my Pulumi account. So each of the kind of plugins that you use, you kind of have to install it to the workspace that you're operating out of. And you'll also need to include these, of course, as part of your poetry installation process. So For DigitalOcean, if I go to the setup file for this, for example, here I am referencing Pulumi DigitalOcean, which can be installed through pip or Poetry. It doesn't matter. Either or works. So I'll go through some of the details once we've actually set up the DigitalOcean module. So this is the DigitalOcean class that I've created. It's just an abstraction above the Pulumi Automation API. This class does lots of kind of different things and uses lots of DigitalOcean products. So if I go to the bottom and quickly skim through what's here, so we've got the VPC being set up, we're creating some buckets, we're setting up the CDN, we're setting up Postgres, Redis, Docker registry, a Kubernetes cluster, firewalls, and a DigitalOcean project. So if I go to my Kubernetes cluster, for example, which is here, this is me creating a Pulumi resource, and this is going to be the name of my Pulumi resource. So I'll be associated with the environment. So if this is for my dev environment, it'll be like dev hyphen whatever the name of the project is plus DigitalOcean K8 cluster. So it's easy to identify what it actually is later on. And then one of the things with Pulumi to kind of note is that it behaves very similar to, say, promises in JavaScript, for example. So a Pulumi output is it's just a promise that this resource effectively will exist at some point. It's not going to exist at that exact point within the code. So it's very similar to kind of Terraform in a sense that it automatically detects when one resource is dependent on another resource. So for example, the VPC resource would be used by Kubernetes, for example. So I reference the VPC UID on this line here, but I need to wait for that VPC to exist. So Pulumi will automatically pick that up and identify that for me, and I will wait for the VPC to exist before going on to creating the Kubernetes cluster. So it saves a lot of kind of headache on kind of coordinating the existence of resources, and then it works perfectly when you're trying to delete resources as well. So I will just do the same thing but backwards to just get rid of everything in the kind of correct order, which can be, a nightmare trying to decommission a project. Another thing to kind of note with Pulumi as well is that inside the script here, for example, when I'm dealing with Kubernetes in particular, I've had to implement a thing called a sleep within Pulumi. So Kubernetes on DigitalOcean, it takes a few seconds, it takes a few minutes for the node pool to become available. So the Kubernetes control plane is kind of treated separately to the node pool on DigitalOcean. And what happens is that you'll request for a cluster to be created on Kubernetes. It will acknowledge that and it will respond back almost immediately that the cluster is ready, but you need to add an additional delay for the node pool to become active, and then you can go on to perform subsequent actions like applying Helm charts, for example. So if I didn't have this sleep in place, what would happen is that the cluster would create in Pulumi, and then I would immediately try and apply the Helm charts, but because the node pool doesn't actually exist or isn't set up yet, the Helm chart phase will just immediately fail because it can't fully function without any kind of nodes in the cluster. So I've set a 300-second delay on create and a 300-second delay on destroy here. So that's just another kind of thing to note. And then another kind of thing that I've noticed as well within Pulumi is that whenever you're trying to output things to files or output things to strings, because things are treated in the form of promises, you have to wait for those outputs effectively before performing any kind of string manipulation. So an example of this is inside the Kubernetes setup PY. If I scroll down here, and then if I go to the Datadog section, so what I'm saying here is that this is effectively chaining the promises together. And what I'm saying here is when all these resources are set up and done, then just run this Lambda function, which just generates a YAML file, just a string operation basically. And then it will apply the YAML file to my cluster. But if I try to run this immediately, the file will output like in-memory object representations rather than the actual concrete values that you would expect. So just another kind of caveat to watch out for with it, within the Pulumi Automation API. And another thing as well is that whenever I'm using the Kubernetes module, I have to kind of explicitly state the provider. So this options line here, resource options, I'm saying the provider is the K8 provider, which is passed in from the DigitalOcean setup PY. So if I go to the Pulumi create stack file, for example, so here's the kind of main event where, if the environment is staging, dev, or production, it will set up Auth0, it will set up DigitalOcean, it will set up Elasticsearch, and a K8. So the K8 provider originates from the DigitalOcean module after I run the setup function. And obviously, as I mentioned earlier, we have to wait for the Kubernetes cluster to come online. We do our 300-second sleep, and then that guarantees when it comes to running the Helm charts that everything's ready to go and the Helm charts won't all immediately fail, which is what would happen otherwise. And then another nice thing here is that we are also using 1Password. So every secret generated part of this script is stored in the vaults, and it's very easy to control what vaults are accessible in which environments, which is super powerful and kind of keeping high security. So that's kind of a quick whirl through of the kind of Pulumi Automation API. I've also included a GitHub workflow example here as well. So this is effectively how to deploy the full stack from your GitHub repository. So this is how you would build your Docker images, push your Docker images, how you would access your secrets in 1Password. So if I look at this here, for example, I've got the 1Password CLI action, and it will fetch the secrets, and I can use those secrets within subsequent steps, which is super easy to do. I'm also building my NextJS web applications, and the build process itself needs to be able to access some of these secrets, so I can pass them through. And here's I'm building all the static files, pushing them to my CDN, pushing the source maps to Datadog, deploying to the actual cluster. So this step just involves replacing the Helm values, and then once you've got your values file ready to go, it will then go on to apply the Helm chart in this step here. So I've done all this in a previous step, and you can see all the deployments are running in here. And then if you want as well, you can check out the Helm chart that I've created for this Pulumi deployment. So the Helm chart's just located in here. And then that's just a quick overview of all the kind of contents included within this Pulumi Automation API script. And then, one of the things as well that, really like about this as well is the proxy ingress as well. I might have mentioned it previously, but it works really nicely with Kita. And, it's super easy to scale the whole thing out horizontally and maintain a certain latency threshold as well, which is super nice. But yeah, that's kind of a quick overview of the Pulumi Automation API script. And feel free to dig more into each of the kind of individual modules. Just wanted to kind of highlight the main things with this repository. And it takes 10 minutes to run. And this could effectively sit within a REST API call, and you could create a front end for this as well. So this could be, an equivalent of a IDP, like an interactive development platform, similar to Backstage, for example. So you could create a simple front end web application for building out your project infrastructure. Just hit that endpoint, and 10 minutes later, it's ready to go. And that's it for me. And thanks again for watching. It's great to see the subscriber count grow, and just don't forget to like and subscribe. It really helps me out too. Thanks again. Bye.